All right, 3.3, we get into systems of inequalities and how we graph them. So we'll get right into it. Example 1 says determine if 5, -9 is a solution to the system of inequalities. So we've already talked about solutions. Solutions make every equation true. In order to be a solution, it has to make all the equations true. So in this case, it has to make all the inequalities true. Something went wrong here, so I'm going to just cross this out. Let's change that into x is greater than 2. Okay, just because I know it was weird there, so I'm not sure if that's what you have, but I'm going to call x is greater than 2. So if we take our ordered pair and we substitute them in, we would get 5 is greater than 2. Is that true? Yes, that is true. Then we take the x and y and we put them into our second inequality. So it's 2 times 5 plus -9 is less than 4. Okay, 2 times 5 is 10. 10 plus -9 is 1. So is 1 less than 4? Yes, that is true. So is this ordered pair a solution to the system? Yes, it is, because it makes all of them true. It can't just make one of them true, it has to make both of them true to be a solution. So in the second part, we talk about how we can graph to determine the solutions of a system of inequalities. Because there's more than just one answer. There's actually infinitely many ordered pairs that will make a system true. Sorry, not always infinitely many, but there's more than one in most cases. So graph to determine the system of inequalities. All right. Again, we have kind of a messed up symbol there. Let's call this greater than or equal to. All right. So if we're going to graph these, we take the first equation, x minus 2y is greater than or equal to 3. To graph this, we have to solve for y. So cancel out the x by subtracting it. So it's negative 2y is greater than or equal to negative x plus 3. Divide by negative 2. What happens when you divide by a negative 2? Or any negative? You have to flip your inequality. And this becomes negative over negative is positive 1/2 plus negative 1.5. So this is the equation we're going to graph. I'm going to graph this in red. So the y-intercept is negative 1.5. The slope is positive 1 over positive 2, so up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. And once you have a handful of points, that's probably good enough. Now, is this going to be a solid or a dashed line? Based on the symbol, this will be a solid line. So solid line. And then it says y is less than or equal to 1/2 x. So less than or equal to means shade below. So I can't do this because of my iPad, but what you can do is you can either just draw arrows or you can shade really lightly. I can't shade lightly. So I'm just going to kind of draw arrows just so I know down below is where I'm going to shade. If I had a pencil, I would just shade it really lightly. Because then we graph our second equation. The y-intercept is negative 4. 1, 2, 3, 4. The slope is positive 3. Up 3, 1, 2, 3, to the right 1. Up 3, right 1. Up 3, right 1. And this is going to be a solid or a dashed line. This will be a dashed line. And it says y is greater than, so you shade above. So if you look, where will these two overlap? if it's above the red line, or above the blue line and below the red line. The overlapping region is going to be, and actually here, I can do this with a highlighter. So we shade above the blue and below the red. So where do they overlap? Right here, this area. So then what I would do is, since you shaded lightly the first two times, wherever they overlap, just make it darker. So the solution is going to be where they overlap, because it has to make both of them true, right? So it's going to be this dark region here. Okay, so the boundary lines are y equals 3x minus 4 and y equals 1/2 x plus negative 1.5. Those are the boundary lines. And the solution occurs where the shaded regions overlap. So wherever your shaded regions overlap, that's the solution. Not just where it's blue, so not just here, not just red, where they overlap. So in the bottom left corner. Okay, so we're looking for overlapping regions when we graph these inequalities. So we have a couple more to practice. And I don't know why these symbols got screwed up, but let's make this a greater than 0. And let's make this let me think. Let's go with greater than 1. Hopefully that turns out okay. So the first equation, I'm going to graph in red. X is greater than 0. Is this a Hoy or a Vux? If it's X, Hoy or Vux? This is going to be a Vux, so it's vertical at 0. And it's going to be a dashed line. So I'm going to make a dashed line at 0. And which way are we going to shade if it's greater than 0? Greater than 0 would be shade to the right. Then we graph the second line. It's a y is greater than 1. So y would be Hoy, because it's got a y equals. That means horizontal. It is also a dashed line. And it is dashed because it says greater than. So it's y is greater than, so it's a dashed line. Okay, so we are going to shade, since it's greater than, we shade above. So it's above that blue line. So far the overlapping region is the top right. Then we got to graph the last equation. Oops. So we solve for y by subtracting 2x. We get y is less than negative 2x plus 4. So this means you go up to 4. 1, 2, 3, 4. And the slope is negative 2 over 1. So down 2 over 1. Down 2 over 1. This is also a dashed line because it says less than. So a dashed line. And where do you shade if it says y is less than? You shade below. So where is the overlapping region? It is this triangle right here. So that triangle is your answer. So you want all three overlapping, the yellow, the blue, and the red, and that's in that triangle. Example 4. X is greater than negative 2. Since it's x equals, it's Vux, so it's vertical. So go to negative 2. And this is actually a dashed line because it's just a greater than. Then it's x is less than 3. So go to 3, 1, 2, 3. This is also a dashed line. Okay, I got ahead of myself. For the first one, x is greater than negative 2. That means you would shade to the right. The second one, x is less than 3. Less than 3 would be to the left. So where do they overlap? They overlap in the middle. So your solution would be this red part where they overlap. because the solution is where all of them are true. So where all of the colors overlap. Again, what I would do with the pencils, I would shade really lightly to the right of the black line, then shade to the left of the black line. Once you know where they overlap, make it nice and dark. Okay, and then we have the very last one where there's 4 different equations. Let's make this one greater than -3 and less than or equal to, I'll rewrite it, x plus 3y is less than or equal to 12. Okay, that'll make it easier. So let's actually graph that one on the bottom first. So we have to solve this for y. So we subtract x. And by the way, I just made a symbol up because when I transferred this onto my iPad, some of the symbols went missing. So I made up it's less than or equal to 12. I hope yours is the same. So if we subtract x over to 12, we would get 3y is less than or equal to -x plus 12. And then, how do you get rid of a times 3? You divide by 3. Y is less than or equal to -1/3 x plus 4. So if we graph that, the y-intercept is 4. The slope is -1/3. That means down 1 to the right 1, 2, 3. Down 1 to the right 3. And then is this a solid or dashed line? Solid line because it's less than or equal to. And then since y is less than or equal to, that means less than means we shade below. Okay, and I would just shade real lightly if I were you with a pencil. Then let's take the equation above that. We'll do that one in blue. So y is greater than 3x minus 1. So -1 is the y-intercept. The slope is 3, which would be up 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And is this solid or dashed? This will be dashed because it just says greater than. So dashed line. And where do we shade if it's y is greater than? Greater than would be shade up. So you shade above this line. So notice I would shade real lightly, and you'll see where they're overlapping right now, but we're not done yet. Now let's graph the line above that. X is greater than -2. X would be vux, so vertical. So go to -2, and this is going to be a dashed line. So dashed line at -2, and it's greater than, so we will shade to the right. It's getting kind of messy right now, but you can see the overlapping part is a triangle right now. To the right of the green line, above the blue line, and below the red line. So the last one we will do in yellow. Y is greater than -3. So that means we will go to -3. Right here. Greater than means a dashed line because it's just a greater than. So dashed line at -3. And then we will shade above because it's greater than. So where do they overlap? It's going to be right here. Below the red, above the blue, above the yellow, to the right of the green. So it's going to be this region right here. Right? And that's about the most you'll have in one problem is have 4. It gets kind of tricky when there's more than that, so we just do 4. So just remember, is it solid or dashed line? Do you shade above or below? And then once you find out where it overlaps, shade that really dark because that's going to be your answer.